Okay, those of you who know me well, I'm sitting there literally telling myself after I shut it off the last recording, I'm like, boy, I'm cranking these notes out. And then I'm sitting there thinking, oh, I hope they understand me. So you know how my ADD mind starts working like that. But the next one is just memorize this. This is probably the most often forgotten theorem of this whole section that I teach. It's actually one that's kind of fun when you work with it. It's the following. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So the cool thing about this one is when I look at these, I know these two angles are going to be supplementary and these two angles are supplementary. Now, here's the thing. It also says encircle E, so there's no E here, so I'm going to make an E there real fast because it's driving me crazy. You have to understand the why behind this. So let's look at just two angles here. I'm going to put these two in black. I want to look at A and C. Obviously, they're not the same size, so I'm using two different marks. But I want you to look at their intercepted arcs. Angle A's intercepted arc goes from here to there. Angle C's intercepted arc goes from there to there. Now, remember it says the two angles are supplementary. Well, think about the common sense why. If I have an inscribed angle, it's half the intercepted arc. Well, what's the sum of their two arcs? 360. Well, what's half of 360? 180. So you know those two angles are always going to have to add up to 180 degrees. So this next one, they say, find the measure of angle G. So that's where I want to go. Now here's what do I have? I have an inscribed quadrilateral. Now, how is that going to help me get there? How am I going to get there? I'm going to use the rules about inscribed quadrilaterals. What do they say? Well, they tell me that my opposite angles are supplementary. So I can sit there and say, oh yeah, I know the measure of angle J plus the measure of angle G equals 180 degrees. Make sure you remember what supplementary is. So then it's just going to be 6b plus 20 plus 3b plus 25 is equal to 180. So I get 9b plus 45 equals 180. Subtract 45, that's 135. Divide by 9. B is going to equal what? 15. Then we have the measure of angle G. What do we get here? We get 3 times 15 plus 25. So I get 45 plus 25 equals what? 70 degrees. I like this, and what I like about it is if you know the rules, this is really, really simple to get. I don't even have to know the intercept arcs because I know the rules. Now guys, and here's another thing, have you noticed I keep marking up the diagrams, even in the theorems, so I want to make sure I have those. And this last one is really no different than what we've already been doing. And what that is we are using another different type of angle. This is actually called a tangent secant angle, or you could call it a tangent chord. It just matters if you start and stop inside the circle, that type of thing. But here's the thing. It's all about the location of the vertex. Notice where I'm marking it. It's on the circle. And if I draw or show where my intercepted arc is, which I'm going to put in yellow, because it's everything between the sides of the blue papers, and I used to call these really fancy names. I used to call them the magic arc finders. Ooh, I know, you guys get so excited for me. But anyway, there's still one intercepted arc. Well, here's the cool thing. You don't treat it any different than what you did before. If the vertex is on the circle and I have one intercepted arc, I know the measure of the angle, this angle right here, is half the measure of its intercepted arc. So, let's write down half the measure of the intercepted arc. All right, so let's just write it down. The measure of angle ABC equals 1/2 the measure of arc AB. So I really treat them no different than what I've been doing because I asked myself this question: where is the vertex? The vertex will tell you what to do. If it's on the circle, you have one intercepted arc and you take half of it. So let's look at the first one. I want to know the measure of angle EFH. So I throw this on here and I'm like, all right, here's angle EFH. Its vertex is on the circle and I have one intercepted arc. Well, the rule tells me, how am I going to get there, is that I get half the measure of the intercepted arc. So the measure of angle EFH is going to be 1/2 of 130 degrees because that's its intercepted arc, which equals 65 degrees. And then we can go the other way around, and this is what I really like. Like here, I want to know the measure of arc GF. Here's this minor arc over here I want to know. I'm looking at it, I'm like, ooh, it has an intercepted, it's intercepted by a tangent chord angle, but I don't have the measure of it either, so I'm kind of stuck. But I can use the fact that I have a linear pair. Nothing changes with linear pairs. If there's a linear pair, you get a linear pair. So if this is 120, I know this one's going to be 58 degrees. Here's the cool part. Now that I know the angle, how am I going to go to the arc? Well, I'm going to do opposite. Instead of dividing to get the angle, I'm going to multiply to get the arc. So it's 2 times 58. So what's that going to be? 116 degrees. Hopefully that kind of keeps you going on this. And now I'm going to do just a couple examples on the other page that I didn't do in notes in class because I want to show you exactly how easy these are. Let's look at the next one again. I want to know the measure of STU. Its vertex is on the circle, so I'm looking for its intercepted arc. Oh, look, it's 166 degrees. So it's just 1/2 of 166 degrees. I'm going to get 83 degrees. Okay? Then let's go to the other one. I want the measure of arc SR. If I know the angle, I'm going to double it to get the arc. So I'm going to go 2 times 71 degrees, and that's going to be 142 degrees. Now, I want to do one more over here, and I actually want to skip down to B. And here with B, it's pretty simple. I know the angle, I look for the intercepted arc, and I double it. Notice how I extend this? So Y is just 2 times 50. That's going to be 100 degrees. Do the same thing going this direction. Here's my intercepted arc, here's my angle, so that's 2 times 70, that's 140 degrees. And then the neat thing here is I know the 3 angles of a triangle add up to 180, so 70 plus 50 is 120, which leaves this one to be 60 degrees. I double it. Isn't that cool? You can get all those arcs by going the inverse way, like I double the angle to get the arcs. Hopefully this will give us some cool ideas and make sure it works great.